Okay, here's exam 3, problem 13. And in this one, we had an n of 20, an x bar of 12, sample variance of 2, and it asks, do you think it's reasonable to that mu might be 11? And the idea here is we could use the confidence interval to try to answer that, because again, the confidence interval, if I've got my x bar here and I make, say, a 90% confidence interval, something like that, then what that's saying is the probability that the real mu is in here is 90%, and the probability that it's outside of that is 10%. So I'll use a confidence interval to help me out with that. And so, I need my x bar plus or minus. Now, n is only 20, so I really probably ought to use a t, t sub 19 degrees of freedom, and my alpha over 2, and then times my s, so I've got square root of 2 over the square root of n. So actually, let me just do that as a over the, or times the square root of 2 over 20. Oops, jumping ahead of myself. And so this is a 12 plus or minus my t and square root of 1 over 10. And so, really what I need to do is kind of determine this thing. And if I go looking up t values somewhere, so for instance, I have a textbook that I trust the t values in, and if I go to 19 degrees of freedom, I see things like t of 0.05 over 2 for 19 degrees of freedom is equal to 2.09. If I take that out to like a 98% confidence interval, t of 0.02 divided by 2, 19 is like a 2.54. And I can go clear out to like a 99% confidence interval. And if I use something like Excel, I could probably figure out even bigger numbers, but this is a 2.86. Now, so, what I need is for this number to be bigger than 1, so because I want to get to 11, so that would be 12 minus 1 is 11. So this thing has to be at least 1, and so my t has to be at least the square root of 10. Okay, but the square root of 10, that's bigger than 3. And so what that tells me is that, even under a 99% confidence interval, so, well, do it here. Here's 12, here's 11, and my 99% confidence interval looks something like that. And so that means, if there's a 99% chance the real answer's in there, then that means there's a 1%, only a 1% chance that it's out here somewhere. And well, it's as likely to be out to the right as to the left. So I'm down to a 0.5% chance even that it could be 11, and or somewhere out in that direction. And so, when I look at that, the fact that this confidence interval, 99% confidence interval, doesn't even contain the number 11, I'm going to say no. I don't think so. I don't think the real answer is 11. I think it's somewhere closer to 12. Okay, so that's the idea for number 13.